This video will cover the concepts of tables and keys and how they are used to structure relational databases. Before we begin, I'd like to stress that the example used in this video is a very simple one that is purely for illustrative purposes. Let's design a simple relational database using fictional student data for a school we'll call ABC University. We have the following information for each student at ABC: first name, last name, email address, age, and course schedule, which includes the course number and course name for each course. Knowing that the data in relational databases is stored in tables, how do you think we should structure the tables to hold the student information? We could just put all of the info into one table, but doing so would introduce some problems. One of the goals in structuring a relational database is to eliminate redundancies and inconsistencies. If we include course information in the student table, we run the risk of duplicating information since each student will likely be taking multiple courses. Having different kinds of information in different places is also conceptually messy. It could get confusing. Best to keep similar items in their own tables so things don't get more complex than they need to be. With that in mind, let's create two tables, one for students and one for courses. We'll start with the students table. The column names will be first name, last name, email address, and age. Each record will be represented by a single row. This is a great start, but we've got a slight problem. We want to make sure that each row in the table can be distinguished as a unique record, but right now we haven't done that. We have two students with the first name Matt. Duplication. What's worse, as the table grows, so does the possibility of other repeated information. To solve this, we need some way to make each row unique every single time. Luckily, we have just the thing, a primary key. A primary key allows each row to include an identifier that is entirely unique to that row. This helps us to identify the exact record that we want without mixing anything up. To accomplish this, a primary key must be entirely unique without any chance of accidental duplication. To capture it, we'll add a column to the first column on the left and call it Student ID. This column is guaranteed to have a unique value for each row because we are generating it ourselves. You could argue that a student's first and last name together would work as a unique identifier, but there is still the chance that two students can have identical first and last names. There is also the possibility that a student's name changes, whereas the student ID will not. Now that we've got the student table situated, let's create a table to store the course information. The columns for this table will be course number and course name. Because the course number is a unique identifier for each course, there is no need to generate a primary key for this table. The course number is what we call a natural key, and it is fine to use in this instance because it is unlikely that the course number will change. Okay, great. We have two tables in our database and we've populated them with some data, but at this point we have no way of relating them. This problem arises because although we have two tables, each with keys, we are lacking certain key relationships. For instance, how will we know which courses each student is taking? To solve this problem, we need to create another table. This table's entire purpose will be to serve as a bridge between the students and courses tables. We'll call this table roster and give it two columns, student ID and course number. Since neither student ID nor course number can uniquely identify a row in this table, neither of those columns alone qualify as a primary key. They are what we call foreign keys, or keys that provide a link between tables. However, when you combine them together, they form what we call a composite key, which uniquely identifies which courses each student is taking. If Ken Jennings, who has student ID 1 in the students table, is taking CS 101 and CS 102 from the courses table, we can add his ID along with the course numbers to the bridge table like so. Amy Schneider is taking CS 103 and CS 104, so we can add that data in here, and then Matt Amodio and James Holzhauer are both taking CS 102 and CS 104. Let's look at the three tables side by side to explore the usefulness of the relationships. Suppose we wanted to know which student is taking object-oriented programming. Because of the relationship between the tables, we can easily find out that it is Amy Schneider. Or, if we wanted to know which courses Ken Jennings is taking, we could discover that he is taking Intro to Programming and Discrete Mathematics. This is all down to the power of relational databases. The way that we have structured our tables, according to their relationships, allows us to quickly and easily retrieve the information that we need. In this video, we've looked at a simplified example of the way a relational database is constructed. We explored the concepts of tables and keys as fundamental elements in a relational database.